Hello, welcome to a video on 30, 60, 90 triangles. On the left, you see an equilateral triangle. All of the angles are labeled 60 degrees. All the side lengths are equivalent. The idea is that if we were to bisect this triangle and it doesn't matter which way you bisect it, I'll bisect it from the top angle down like that. What you get are two equivalent angles that are 30 and 30 degrees on each side. The other thing to notice is that the side at the bottom was bisected. You have these two smaller segments that will be equivalent in length, and they'll also be exactly half of the side of the equilateral triangle. So that takes us to this figure on the right-hand side here. And we had noticed that we have a right triangle, which is this smaller right triangle to the right. We have the shorter leg labeled x, and notice the hypotenuse is labeled 2x, or twice the x, and that's only because, again, remember this shorter leg is exactly half of the entire side length of the equilateral triangle. The thing that we have to figure out is what is going on with b. What is the length of the larger leg? So we're going to examine that by using the Pythagorean theorem. So the Pythagorean theorem would state that the square of x plus the square of b, again, the square of the two legs, is equivalent to the square of the hypotenuse. So if we square the right-hand side, we'll get 2 squared is 4 and x squared. Notice we have an x squared term on both sides. So if I subtract x squared from both sides, I'll get that b squared is equal to 3x squared. 4 minus 1. Taking the square root of both sides, we'll get the square root of b squared is b, the square root of x squared is x. The square root of 3 is an irrational number. I'll just leave that as square root 3. So what do we learn? I mean, what was the whole point of this? Well, the point was to figure out what is the length of b, and what is its relationship with the other sides? Well, notice it says that it's equal to square root 3 times x. Now, what is x? X is this shorter leg length. So what that means, instead of not knowing what b is, we now know that b is exactly square root 3 times larger than the shorter leg x. So that's the relationship between all the sides. The shorter leg, whatever it is, we'll call it x. The hypotenuse will be twice x, or twice as long, and the longer leg will be square root 3 times x. Let's see that used in the context of a few problems. So this is basically another shortcut from using the Pythagorean theorem once you have this relationship memorized. So in these two examples, just identify the parts. So on the one on the left, we have something labeled 10. Well, what is that on this triangle? Well, first of all, this is a 30, 60, 90 triangle, and this is the shorter leg. Okay, that's something to notice. That means using our relationship, we would know that the hypotenuse is exactly twice as long. I don't know why my stylus is deciding to do that there. So the hypotenuse would be 10 times 2, or 20, twice as long. And then the longer leg would be the short leg times the square root of 3. So it would be 10 times the square root of 3. Well, if we use our calculator to approximate that, I can do the square root of 3 and then multiply that by 10 to get our answer of 17.32, or approximately 17.32. All right. So I was able to find all those lengths quickly and efficiently without using the Pythagorean theorem. Let's look at the second example there. Notice in this example, I was given the hypotenuse 20. I'm not going to work this one all the way out, but you could use the same logic to sort of go about it. We know that it's a 30, 60, 90 triangle. So once I know the hypotenuse is 20, that would be like the previous problem, but backwards. I would automatically then say to myself, well, the shorter leg must be half that, or 10. And then once again, to get to the longer leg, I would multiply that by the square root of 3. So you can see now that these two triangles actually here are identical. Let's take a look at the case where you're given the longer leg. So this is the other case. When I have the longer leg, in this case it's labeled 12, what I'm supposed to remember is that it's the shorter leg times the square root of 3. Okay, so you can write out an equation here, but you don't have to. You would just know that the inverse in your mind of, instead of multiplying by the square root of 3, would be to divide by the square root of 3. So if you took the longer leg, 12, and you divide by the square root of 3, you'll come back, and that'll be the value of x, in this case, the shorter leg. Well, I'm going to grab my calculator once again. Let's see. I'm going to